In this video, I'm going to show you how to convert a recurring decimal into a fraction. Now, recurring decimals are rational numbers, and that means they can be expressed exactly as a fraction. And the steps I'm going to show you will work for any recurring decimal. You just sometimes might have to play around with the method a little bit. So we're going to start with 0.3 recurring. So that means 0.33333 and so on. The first step is to let 0.3 recurring equal to x. So x equals 0.3333 and so on. Now the next step is I'm going to find 10x. 10x equals 3.3333 and so on. And then the neat trick here is if I subtract my x from my 10x, I cancel out all the recurring 3's. So 10x minus x is 9x, and 3.3 recurring minus 0.3 recurring just leaves me with 3. Now if I cancel down, I'll get x equals 3 divided by 9, which cancels down to 1/3. And you might have already known that 0.3 recurring equals to 1/3. Let's look at how we use this method for 0.25 recurring. Now the dot is above the 2 and the 5. That means that the sequence 2, 5 is repeated. So let x equal 0.252525 and so on. In this case, if I multiply it by 10, 10x would equal 2.5252 and so on. And then the 2's and the 5's would not cancel out when I subtract. So instead of taking 10x, I'm going to take 100x. Okay, that way the place value we're shifting to the left, we're shifting twice to the left in terms of place value. So we get 25.252525 and so on. Now when I cancel out 100x minus 1x, I get 99x, and all those 5 recurrings cancel out, and I'm left with 25. Now again, I can solve for x, so x equals 25 divided by 99. Now 25 and 99 don't have any common factors, so I can't simplify any further. So 0.25 recurring equals 25 over 99. Third example, 0.135 recurring. Now here the dot is above the 1 and the 5. That means that the sequence of numbers 1, 3, 5 is recurring. We put the dot at the beginning and the end of the recurring sequence of numbers. So here, let x equal 0.135135 and so on. This time, we're going to multiply by 1,000 because we want to shift all our digits 3 places to the left. So 1,000 x equals 135.135135 and so on. Here, when I subtract, the 135's will cancel out, and I'll be left with 999x, not 1,000x, because we're subtracting 1x. So 999x equals 135. From there, we can solve for x. So x equals 135 divided by 999. That cancels down. We can divide by 3 to get 45 over 333. And we can cancel down dividing by 3 again to get 15 over 111. So 0.135 recurring equals to 15 over 111. Final example is a little bit different here because just the 4 is recurring in this 0.124 recurring. So let's let x equal 0.12444 and so on. And then we'll find 1,000x. So 1,000x is 124.444 and so on. Now if I was to cancel down, my 4's would not cancel down with the 1 and the 2 here, these digits which are in the decimal places. So I'm going to try finding 100x. because I want to shift these digits, the 1 and the 2 places to the left, so that I've only got 4s in the decimal places. So 100x will be 12.444, and so on. And now I can see that if I subtract 100x from 1000x, then the 4 recurring will cancel out. So that gives me 900x equals 124 minus 12, which is 112. There we can cancel down by dividing by 2, I guess. So that would give me, oh, first of all, we've got to solve. X equals 112 divided by 900. Then we can solve by dividing by 2, so 56 over 450. And I can divide my numerator and denominator by 2 again to get 28 over 225. And I don't think that I can simplify that any further. So 0.124 recurring equals to 28 over 225.